Alright, this is the 6-1 notes. It's not too hard stuff as long as you know how to convert from standard form into slope-intercept form, and we'll go over that here in a second. So there are three different ways that you can, three different answer choices that you will have on these problems. One is this first one right here, this first little box. And so all this is saying is that when you have two lines, if they intersect, you will have an answer, and it'll be right here where those two lines intersect. So you have exactly one solution. Okay, the second scenario that can happen is number 2. That's where when you graph it, you have the exact same line. So think about having like two pencils and putting them right on top of each other. They touch at every single point on there, and there's too many points on there to count. And so that's why we have here there's an infinite amount of solutions. And the last scenario that you can have is you can have a set of parallel lines. And as you notice, they never ever ever touch. Okay, so here's like my first line, here's my second line. They don't ever touch, they never intersect. If you don't have an intersection, then you don't have a solution. So that's why your answer here is no solution. So there's 6 problems that we're going to go through. You're going to see every single one of these scenarios play out. So here we go. We're going to go ahead and start with this first one. So the first one we have y is equal to -2. Y equals -2. It's already solved as a y equals, so we can go ahead and graph this. So y equals -2 is going to go through your y-axis at -2. So it's going to go through right here. So what I'm going to do is just make a line right here at y equals -2. And it's a little bit above it, but it's okay. Okay, so here's y is equal to -2. And the second graph that I have is 3x minus y is equal to -1. So what I need to do is put that into slope-intercept form. So I'm going to write that down here. So we have 3x minus y is equal to -1. There's 2 steps to put an equation into slope-intercept form. The first one is your exciting move, and that's because you have to move the x. So you have a -y left over. The positive 3x is going to become negative, and you have a -1. The second thing is your great divide. So we're going to divide everything in here by a -1. So when you do that, all it does is change the sign. So the negative becomes a positive, and the negative becomes a positive. So here is my second graph. Now, if you remember from quite a while back, this is in slope-intercept form. And the reason why we put this in slope-intercept form is because you have two things. You have your slope, and you have your y-intercept. Your y-intercept is your starting point. So I'm going to be starting at the point 0, 1. And then your slope, that is your rise over run. So that tells you where to go to plot the next points. And since it's a whole number, you put it over 1. Okay, so I'm going to go ahead and plot this line. So I'm starting at 0, 1. So x is 0, y is 1. And then I'm going to go up 3 and over 1. So up 1, 2, 3 over 1 would be off the chart. Down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. I'm going to go ahead and connect my lines the best that I can. That is not pretty. Okay, there we go. So now what you need to do is you just want to find where your two lines intersect. Well, my two lines intersect right here at this point. I'm going to go ahead and circle that. I'm just going to draw an arrow over here, and that point is at -1, -2. So my solution for these two lines right here is at -1, -2. And that's it. That's all that you have to do. Okay, so over here we have x is equal to 2. So this is kind of like the first one, except instead of y equals, it's x equals. So if it's x equals, it goes through the x-axis, and it's going through the x-axis right here at 2. So since it's cutting through the x-axis, it's going to go straight up and down. So there's my line at x equals 2. And then my second line is a standard form, 2x plus y is equal to 1. So 2x plus y is equal to 1. We're going to put that into slope-intercept form. Okay, so to do that, we're going to do our exciting move. So I have y equals, because that's all that I have left over. Positive 2x becomes negative. Your second step would be to do your great divide. Well, if you notice, it already says y equals, so you don't have to do a great divide. So what we have here then is y equals mx plus b. So I know my starting point is going to be at 0, 1. And I know my slope, which is my rise over run, is going to be a -2. Okay, so I'm going to put that over 1. So we're starting at 0, 1. So 0, 1. Oh, I'm going to change my color back to the graph. Okay, so 0, 1. And since it's a negative, we're going to go down. So I'm going to have to go down 2 and over 1. So down 2 over 1, down 2 over 1, down 2 over 1, up 2 over 1. We'll go ahead and connect those dots. Okay, and where those two lines meet, so this point right here, that intersection, that is my solution. So my solution here would be 1, 2, negative 1, negative 3, or sorry, negative 1, negative 2, negative 3. So positive 2, negative 3 is my solution for those two lines. All right, and the last one, so we have y equals 1/2 x. That's already in slope-intercept form. So for this one, my slope is 1/2, and I know that my starting point, since it's not adding or subtracting anything, is at 0, 0. So I'm going to start at the origin here. I'm going to go up 1 over 2, up 1 over 2, up 1, I can't go anymore. And then I'm going to go down 1 over 2, down 1 over 2, and I'm going to go ahead and connect my dots to make my line. So there's my first line, and then the second one, x plus y is equal to 3. I got to put that into slope-intercept form, so x plus y is equal to 3. First you do your exciting move, so y is equal to, it's a positive x, so it's going to become a negative x, and I don't have to do a great divide here because it's just y equals, which is what I want. So y equals mx plus b. Okay, so I know that my starting point is at 0, 3. And I know my slope here is going to be negative 1, so I'm going to put it over 1 for my rise over run. So I'm starting at 0, 3. So 0, 1, 2, 3. So 1, 2, 3. And my slope is a negative 1, so I'm going to go down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Do the opposite, up and left, and connect my dots. And so I'm going to go ahead and find my intersection, which is this point right here. And that point is the answer, to, the solution to these two graphs. And so it's going to be at 1, 2, 1. So 2, 1 is the solution for these two equations. Okay, so for this system, your solution to answer is 2, 1. All right, we just got 3 more on the back side to do. Okay, so for this first one, both of these are in standard form, so I'm going to have to convert both of those into slope-intercept form. So the first one is 2x plus y is equal to 6. So first you do your exciting move, so I just have a positive y left over. The positive 2x becomes a negative, and I don't have a great divide because it's just y equals. So I'm starting at 6. So 1, 2, 3, 4, 5, 6. And my slope is a negative 2. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Connect your dots. Okay, and then I have my second equation, which is 2x minus y is equal to a negative 2. So again, we're going to do the exciting move. So negative y is equal to, the positive 2x becomes a negative minus 2. And here you have to do a great divide because you need this to be a positive y. So we're going to divide everything by a negative, so you have y equals. When you divide just by a negative, all it does is change the signs. So a positive 2x and a positive 2. And now I can go ahead and graph that. So I have a positive 2 for my y-intercept, and my slope is 2. So I'm going to go up 2 over 1, up 2 over 1. I'm going to go down 2 over 1, down 2 over 1. So I'm going to connect my dots here to make my line. And where my two lines meet, where they intersect right here, this is my solution. So the solution to this system is my x value is 1 and the y value is 1, 2, 3, 4. So the solution to this system is 1, 4. Okay, so number 5, again, I have two equations that I need to put in a slope-intercept form. So the first one I have is 3x plus 2y equals 6. So 3x plus 2y is equal to 6. You do your exciting move. So I have a 2y left over. Positive 3x becomes a negative. And I have the great divide. So I'm going to divide everything in here by 2. So we have y equals, this is just negative 3 over 2x, and 6 divided by 2 is 3. So my y-intercept is at positive 3, so I'm going to start at 1, 2, 3. And my slope, I'm going to go down 3 and over 2. So down 1, 2, 3 over 2. Down 1, 2, 3 over 2. And see if I can do it the opposite way. Up 1, 2, that's off the graph. So this is as far as I can go. So I'm going to go ahead and connect my dots. Oops. Okay, and draw my arrows because it's a line. And now we're going to do the second one. So 3x plus 2y equals negative 4. So 3x plus 2y is equal to negative 4. Exciting move. So we have 2y is equal to negative 3x minus 4. And great divide. So divide everything by 2. So I have y equals negative 3 over 2x minus 2. Now I can already tell you what the answer is going to be without even having to graph this. And so here's why. Okay, my slope here is a negative 3 over 2. My slope here is a negative 3 over 2. When you have the exact same slope, what kind of lines do you have? You have parallel lines. Okay, well parallel lines never touch, which means you have no intersection, which means you have no solution. But we're going to go ahead and graph it anyway. So I have a negative 2 is my y-intercept, and then my slope is a negative 3 over 2. So I can't go down 3 and over 2, but I can go up 3, 1, 2, 3, and over 2. Up 1, 2, 3 over 2. And so I can go ahead and connect these dots, and that's a horrible connection of those dots. So let me try that again. Okay, so that's a little bit better. So there's my line, and as you notice, there's parallel lines. So if I were to say, hey, find the intersection, there's no intersection. So since you have parallel lines, okay, and which means they never ever touch, no intersection at all, your answer here would be no solution. All right, and the last one. So first I need to convert that first one into slope-intercept form. So we have 2y is equal to negative 4x plus 4. So all you have to do here, you already have the exciting move done. All you got to do is your great divide. So you're going to divide everything in here by 2. So y equals negative 4 divided by 2 is negative 2, and 4 divided by 2 is 2. So my starting point is my y-intercept, which is the positive 2, and my slope is a negative 2. So down 2 over 1, down 2 over 1, down 2 over 1, to the opposite, so up 2 over 1. Go ahead and connect the dots. And then my second graph is already in slope-intercept form, so that's really nice because I can graph my line. Now, here's something else that you don't even have to graph this line because what do you notice? They're the exact same equation. So if you were to graph this line, you still would be here at 2. You go down 2 over 1, down 2 over 1, down 2 over 1, up 2 over 1, and you will have the exact same line. Okay, whoops, there we go. So what this means, you can kind of see the red and the green, okay, how they're on top of each other. So just think about, like, take your pencil and another pencil, put them right on top of each other. Those pencils will touch an infinite amount of points. So they hit all the way up and down on that line. And so here what you have is you have the exact same line. So when you have the same line, the same equation, your answer here is going to be infinite solutions. So that means if I said, hey, show me with your finger where those two pencils touch, there would be a bajillion places that you could pick. So your answer here, though, would be an infinite amount of solutions. And that's it. That is how you do 6-1.